So yesterday we have seen how monitors are being developed here. So this is the way a monitor is being developed. Already have sent this message. I mean this sample generation or sample code, which is useful to you to generate the so select all. Why it is not copied? Okay, so already I have given this one. So if you do understand, yes, it is something. Things are there here. Okay, everything is there here. So if it is something like this, if a semaphore of one particular resource is less than or equal to 0, then you will be put into waiting state, and the so-called process, whatever the process is trying to access this particular X, will be put into sleep. So suspend by itself. And if this could be whenever this particular x less than or equal to xs less than or equal to 0 will be done by some other process by executing so this signal, then so xs minus minus is going to be executed by this particular wait here. So this is the general process where exactly which is being done in terms of semaphores. I mean monitors, not semaphores actually, monitors here. And the signal will be taken by any other kind of processes. Directly the success value will be gets increased, and whatever the most recent process, that process is going to executed by the monitor here. Okay, and here get the value of the parameter. Let me say that is x in the sense if parameter will be equal to x, x will be taken, otherwise y will be taken, something like that. If a set parameter, if any modifications will be done by you, those modifications will be so supplied as a parameter. If this particular parameter will be equal to x, okay, let me consider. I'd like to take one more thing here, that is value, whatever the value you are trying to take. So that particular value, of course, it is not at all a pure program. Don't worry about this modifications. It is not at all a pure program. So therefore, need not to be worry about this one here. Then something like this, it is going to be done based on the shared variables, and shared variables will be always taken into consideration. So for default, I mean here you can see. So installation code will be taken here. That is installation code will be gets available here. So therefore, your process is, I mean your shared variables are supposed to be so initialized here based on the monitor, what exactly the monitor has taken. If process 1 is being executed something like this, monitor m has been taken by the process 1, and while it is true, m dot weight of x critical section will be taken. So if this particular thing is not supposed to be so put into this particular thing is not supposed to be put into sleep or suspended temporarily, so it will be taken its critical section. Otherwise, so if this will be gets executed, I mean while xs is less than or equal to 0 will be executed, obviously our process will be under suspension mode. If it is not executed, so that what do you mean by this one here? It is not equal to so less than or equal to 0. So things will not be do something like that, because your x I mean shared variable x is available for you for doing some kind of operations on that. So therefore it will be taken its critical section and do some kind of operation using monitor here. So m is our monitor here. So m dot get parameter and operation on whatever the value you have taken here, that particular operation. So x equal to something you would like to do your own operation, and then followed by so parameter followed by some value can be taken here. So it will be done after performing this critical section. After performing this one, so you have to operate your so signal, and then of course one more very important thing is required here, that reminder section. A reminder so section you need to write while writing while taking something about the critical section and reminder section. That's very important to understand. So this is what about monitor. Okay, a brief introduction in continuation with the previous class. Okay, so this is the brief explanation regarding to so this particular monitor which was taken in the previous class. Now today, I'd like to open the syllabus of you. Probably this is the syllabus of you. So here today we'd like to go ahead and take some kind of information regarding to, so what is that? Readers and writers problem. Readers and writers problem. Let me finish off this one. And the dining philosophers problem, it is actually a critical sections problem only. But I am feeling that my feeling on this dining philosophers problem is when deadlocks is being there, I'd like to discuss this particular problem there, because dining philosophers is always related to deadlocks. It is always related to deadlocks only. So it is purely operated on resources, not exactly. So the critical section, it is purely applied on resources. So obviously, probably you people have got some idea regarding to deadlocks. Things are going on in our class, daily regular class. So during deadlocks, I will discuss this particular. I will recollect to you what is dining philosopher's problem and how this could be taken into consideration. Let me discuss in unit number something like 4. Unit number 4. I'll discuss with you. Okay. So that is what today we'd like to go ahead with the readers and writers problem. So simply speaking, readers and writers problem is a particular problem. MS Paint, I think. MS Paint. It is a specific problem. What exactly the problem is? Normally, if you take any database activity or if you take any other activity as far as the shared area or server sharing area, so normally some kind of processes are trying to take so read operation. Some processes might be taken, so read and write operations. Let me talk about readers and writers. Why he's gone something like this. Okay, you can see readers and writers. Readers and writers problem. So here normally readers and writers problem, you do have 4 different types of activities. Of course, these are not defined by your operating system, but these are defined by databases. Okay, please remember this one. Don't write this one here in operating system. Of course, you may be written, there is no problem at all. But so to be better understanding purpose, I am giving this particular scenario, whatever the scenarios I am trying to explain here. So here, normally, the thing is database, something like this. This is the database. And this particular database is being shared by several number of so users here. Let me take as user 1. So this is user 1, this is user 2, and this is user 3, and this is user 4, something like that. And there is a particular database schema which is available here. Some particular data is there, which is this one here. All these 4 people wants to access that particular database somehow by taking some kind of operations using database operations. So he may be get access this particular database, he may be get access, he may be get access, and so on. So he is also get access. Okay, you may be confused in terms of threads. So let me don't write anything here, anything there. So user 1, user 2, user 3, all people are trying to access this particular database. So accessing will be in so 2 forms. They are in 2 forms. Form number 1 will be read. Form number 1 will be read. Form number 2 will be write. Okay, form number 2 will be write. WRITE. There are 2 forms. So read in the sense it is useful for only reading purpose. Read only. Read only purpose. So you are allowed to read the content of that particular database or that particular file. You are allowed to read only that particular content. Write in the sense it is accepted for only write only purpose. Write only purpose. Okay. While anybody is trying to write, so nobody is accepted to read the contents, to write the contents, to read the contents from the database and to write the contents onto the database or onto the file. You can say any one of them. Okay. So it is not possible here. So whenever you are trying to write onto the particular database, whenever you are trying to write data onto the particular file or database, you must have read write permissions. Read plus write permissions. Both permissions must be there with you. So if both permissions are not there with you, so read only permission in the sense only R permission, write only permission in the sense only W permission. Whereas wanted to modify the file, what exactly the file you are trying to take, that particular modification should be existed with the read and write permissions. Read and write both permissions. Now, if any person is trying to take, so in this context, I'd like to give you in this context, write only permission is not really existed. Of course, in C or C++, something like languages. So third generation languages, you do have some kind of write permission, read only permission, write only permission, read write, that is appending permission, something like that will be there in C or C++. But as far as operating systems and as far as databases are concerned, there is no write only permission. You do have read write, otherwise write. Oh, sorry, read. There is no write permission. Exclusive write permission could not be existed with you. But for explanation point of view, I'm supposed to give you what is read, what is write. Now there are certain number of here I'd like to use a word conflict. Conflict. So when a particular person, let me say a particular process of P1 is trying to do some kind of operation, only I'm telling you that this is only for example, okay, not exactly the operating system point of view. Process of P2 is trying to do some kind of operation. Process of P3 is trying to do some kind of operation. Let me say the database name is what should I take? Schema. SCHEMA. Let me write in terms of process 1, process 2, process 3. Let me write yes. Yes is my schema. So this is the database accessed by this process P1, process P2, process P3. To access this one, process P1 has been operated read schema. It was operated something like that. Many number of people can able to read because I am presenting and you people are looking into the screen. So you could able to read, but you don't have any permission to write. Okay. So read schema, no problem. So it could be accepted. And here also read schema, same schema. So here also, he's also having same kind of permission. There is no problem at all. Okay. And he's also taken read schema. So he's also having so-called permission. So permission will be issued. There is no problem at all. Many number of people can be shared the file in read-only mode. No problem. When this particular person will be trying to write onto the file, then problem will be raises. Then problem will be raises. Of course, he's also taking same kind of activity. He's also do some kind of process and trying to write onto the file. He's also do the same kind of activity. Everybody has to read contents and do some kind of modification and write back to the database. These operations will be done. So when process 1 is trying to perform a read operation, I don't want to write schema at this moment, read operation. Process 2 is trying to perform a read operation again. I'm giving some space here. That is, it is being happen at a delta t naught time and it is being happen at a delta t1 time. That is the meaning here. Now at this particular time, process 1 has taken a write operation. Please consider that write in the sense read write operation. This is by default read write operation. Please consider something like that. When he was taken this particular operation, already you are in read mode and your neighbor process 2 also in read mode. Now you are trying to take read and write mode. So what exactly this could be in the sense, you will be put into deadlock mode. You will be under waiting mode. Okay, you will be under waiting mode. This kind of thing is called as read conflict. Read conflict does means many number of people are trying to take read operation on the shared file. No problem. many number of people. In this context, he was taken read operation. He is also taken read operation. P2 also taken at read operation. He is also taken in the same. No problem. Within this context, P1 unknowingly he was operated read write operation. In terms of databases, it is called as exclusive. Exclusive. The operation name is in terms of databases, it is called as exclusive. Of course, in operating systems, it doesn't. However, read write permission was taken by at delta T2 time. So this particular P1 has taken read write. Immediately, you will be put in deadlock mode. This kind of scenario is called as RR conflict. Understand this problem? All of you. Understand this particular problem?
Yes, sir.
Yes, sir.
Yeah, this is called as read conflict. This kind of scenario is called as that one. Now, when you can consider the same scenario, let me write at this place, P1 is trying to take something and P2 is trying to do some kind of operation. At delta T1 time, he was taken, so read operation. Delta naught time, he was taken a read operation, something like this. At delta T1 time, he was taken read write operation. Look at this, he was taken previously, he was taken read operation, he's also taken read operation, then he was taken read write. Now directly here, P2 has taken read and delta T1, P1 has taken read write operation. Now P1 will be, I'm concentrating on only P1, whether he will be put into deadlock or not. I'm not concentrating on P2. Okay. So here he will be put into deadlock mode because already one particular fellow has taken the read mode. If you are trying to apply read write, so this particular fellow will be get struck. So permission will be given him to read the things and he will be put into deadlock mode. This is called as read write conflict. Read write conflict. First read was operated, then read write was operated. So that is why it is called as read write conflict. Okay, this is the scenario for read write conflict here. This is the actual scenario. Now one more conflict. Probably this is also understood by you. I believe that this is also understood by you. Yes or no?
Yes, sir.
Yeah. Any other? Was it understood? D naught 92.
Yes.
Yes, sir. Agreed.
Okay. Now, yeah. Next conflict will be seen something like this. So process P1 is trying to perform something, and process P2 is trying to do something here. Process P1 is trying to, process P2 at delta T naught time, process P2 was taken, so read write operation on the database, on the schema. At delta T1 time, he's also operated read, so write operation on the same schema. Now he will be put into deadlock. Why? Already the exclusive mode, otherwise read and write whole permissions have been given to process P2, but you are trying to take the same permissions from on the schema by you. So now you will be put into deadlock mode. This is called as write conflict. Write conflict. Okay. So already we have discussed what about read write conflict, in the sense if you change the actors from P2 to P1 and P1 to P2, then obviously that is write read conflict. Okay, first person is taken write operation, second person is taken read operation, then obviously he will be considered as write read operation, write read conflict. Okay, if you don't understand, let me explain. So P1 is taken and the P2 also taken, something like this here. He was already operated. So he was already read rate already it has been completed. Read rate was completed, read. He was taken write or read operation at delta T naught time. Now at delta T1 time, he was taken only read operation. Only read operation. By P1, he was taken only read operation. Now, all permissions were given by this particular fellow, but he is trying to take only read only mode, but it is not accepted because permissions were given to P2. So it is called as write read conflict, something like. Okay, read conflict, read write conflict, write read conflict, write conflict. These are the 4 different types of conflicts are there. Okay, these conflicts were implemented by readers writers problem. These conflicts were introduced or implemented by readers writers problem here in operating system. How it could be done. I believe that you do understand what I'm speaking. If any questions before going to readers writers actual problem, please ask me. Why no response? Why? Emma?
డౌట్ లేదు సార్.
Okay. Andarki.
Yes, sir.
Okay. Then, so talking something about here, this particular thing, either read operation or write operation, if you want to perform these, you are expected to implement 2 different types of things. One is satisfied only read write. Second one is satisfied read and write. First one is only read. Second one is satisfied read and write. So therefore, you need to perform that particular operation. How this could be done here in the sense. So you'd like to take 3 or 4 different kinds of variables. First one is semaphore. Actually, semaphore is a data type as far as operating systems are concerned. RW mutex. So hope that you do understand what is mutex. Mutex is a binary locking system. If it is one, will be available for everybody to open the file. If it is to access the critical section, and if it is 0, it is not possible to access that particular critical section. Okay, that is what. Same semaphore again. Semaphore. So mutex will be equal to 1. So look at this. Hope that this will be understood by you. So this will be taken for read and write operations. This will be taken for read and write operations. Okay, but this will be taken for only read operations. Whenever you are trying to take read operation, then mutex will be gets taken by you. Whenever you are trying to take read write operation, then you'd like to take RW underscore mutex. RW underscore mutex will be taken here. So that is what the point where exactly you need to remember here. Okay. Now, one more thing. So INT, let me take the same color what I am trying to explain here. Integer read count. Hope that you understood what exactly I have explained. RR conflict, RW conflict, WR conflict, and WW conflict, as a read conflict, read write conflict. If you do understand this one very properly, now onwards what I am speaking, you are understand very easily. If any questions here, that is why I'm asking you. If any questions, please ask me. Now, ఇప్పుడు ఏమైనా ఇక్కడ క్వశ్చన్స్ ఉంటే అడగండి. అడిగితే నేను వాటికి ఆన్సర్ చెప్తున్నాను అంటే ఇది మొత్తం క్లారిటీ వచ్చేస్తాయి. ఎవరు రెస్పాండ్ అవ్వట్లా.
No, sir. In question same level, sir.
Okay. Now you can see the scenario. You please understand the scenario. First, suppose process P1 is trying to take RW underscore mutex. Implementation కొద్దిసేపు ఆగిన తర్వాత couple of minutes we'll see. Mutex was taken. Okay, this was taken. Before going to access this one, are there any read count? Read count? Are there any people who are already under read mode? If this will be equal to 0, immediately everything will be given to you. Because nobody is under read count. Nobody is under read count. So there is no problem. RW mutex will be given to you. So all permissions will be given to you to perform the modification operation. When read count will be not equal to 0, for example, it could be some two or more processes, two other processes are enter into, and I mean taken the permissions from you that I am supposed to read the things. I am supposed to read the things. So two people are there with you. At this moment, process 1 is trying to operate RW mutex operation. Okay, two people are under read mode. So same item has been taken under read mode. Now you are trying to take all permissions from the particular item by the operating system. So therefore, this is not equal to 0, so that your RW mutex will be denied. You will be put into deadlock. That is suspended temporarily, and they will be put into so-called queue. Hope that you understood the scenario. This scenario is very important. If you understand this scenario, everything is easy. If you do understand this one, it is very easy to understand remaining all scenarios. Ikkada RW అంటే రైట్ కోసం RW mutex అనేది ఎవరైనా సరే ఒక పర్టికులర్ ప్రాసెస్ అడుగుతూ ఉన్నట్లయితే సెమాఫోర్ ఏం చెక్ చేస్తుంది అంటే రైటర్స్ ప్రాబ్లం ఏం చెక్ చేస్తుందంటే రీడ్ కౌంట్ 0 ఉందా లేదా చెక్ చేస్తుంది. అంటే నోబడి అదర్ పీపుల్ ఎవ్వరు కూడా దీన్ని యాక్సెస్ చేయట్లేదు అని చెక్ చేస్తుంది. దాని తర్వాత RW mutex వాల్యూ 1 ఉందా చెక్ చేస్తుంది. RW, so mutex value is equal to 1 or not. If it must be 0, it must be 1. 1 ante available, 0 ante nobody has taken with read permission. So ee rendu kuda true aithe you will be free to access that particular item. Ee rendu ante idi 0 idi 1 కాకుండా ఇక్కడంతా ఒక 2 ఉండి ఇక్కడ మాత్రం 1 ఉంది అనుకుందాం. అంటే ఇక్కడ ఏం చేయాలి? RC, I mean read count will be equal to, if read count will be equal to 0 and so RWM, let me write RWM. So RW underscore M is equal to 1, then you will be given permission to take the item. ఎవరికి రీడ్ పర్మిషన్ లేదు, ఇంకొకటి రీడ్ రైట్ పర్మిషన్ తీసుకోవాలా. కాబట్టి ఐటమ్ అవైలబుల్, యూ కెన్ take it for granted and you can perform your operation. దీంట్లో ఏ ఒక్క కండిషన్ ఫాల్స్ అయినా, ఏ ఒక్క కండిషన్ ఫాల్స్ అవటం అంటే ఇక్కడ మీనింగ్ ఏంటి? ఫర్ ఎగ్జాంపుల్ you are trying to take when you are trying to access this read route count, then the scenario will be RC will be equal to 1, RWM will be equal to 1. ఒకడేమో రీడ్ మోడ్ లో ఉన్నాడు, రైట్ మోడ్ ఇంతవరకు ఎవరికి ఇవ్వాల. ఎవరికైనా ఇచ్చినట్లయితే 0 అయిపోయి ఉండేదిగా, ఎవరికి ఇవ్వలేదు. కాబట్టి RC ఈక్వల్ టు 0, 1 is equal to 0, which is false, and whatever the thing it might be, it doesn't make any sense. ఎందుకంటే ఒకటి ఫాల్స్ వచ్చింది కాబట్టి అండ్ ఆపరేషన్ లో ఫైనల్లీ ఫాల్స్ అవుతుంది కాబట్టి యూ విల్ బి పుట్ ఇన్ టు డెడ్ లాక్. అర్థమైందా? ఇది సినారియో. ఈ సినారియో ప్రకారం మీరు ఈ రీడ్ రైట్ కాన్ఫ్లిక్ట్స్ మొత్తాన్ని కూడా హ్యాండిల్ చేస్తారు. ఓకే, అయితే ఎలా రాస్తారు? హౌ కుడ్ యూ రైట్ ది సేమ్ థింగ్ హియర్? You can see this is the operation. This is the semaphore what you are supposed to do, right? While true, okay, So first you need to operate in semaphores. First operation will be wait. So you need to take wait mutex. అంటే రీడ్ కోసం వాడుతున్నారు. మ్యూటెక్స్ రీడ్ కోసం వాడుతున్నారు. మ్యూటెక్స్ అంటే యాక్సెస్ కదా, ఎవరికి పడితే వాళ్ళకి ఇచ్చేసేయచ్చు. రీడ్ పర్మిషన్ ఏముందో టకటకటకి ఇచ్చేసేయచ్చు. దెర్ఫోర్ రీడ్ కౌంట్, read underscore count will be equal to, so will be equal to, not double equal to, single equal to, equal to. So let me consider as far as C plus plus, ఎందుకంటే read count అనేది పెద్దదిగా ఉంది కాబట్టి ప్లస్ ప్లస్ అప్లై చేసేద్దాం. If read count equal to 1, if read count will be equal to read count is equal to 1, okay na, wait, so rw underscore mutex, అది ఒకటైతే దీన్ని ఎగ్జిక్యూట్ చేస్తా ఉంటాను. ఆఫ్టర్ పర్ఫార్మింగ్ దిస్ వన్, signal of mutex, okay. So this is the specific operation which could be done, then followed by actual operation. Critical section is being taken here, okay. Read operation is being done, reading is being done, read, so reading is being done, DYNE, done, not okay. Then when we are trying to take wait for one more time, so it will be wait for mutex one more time. At this particular point of time, what exactly the process will be do here in the sense, read count will be, read underscore count will be decreased. Previously increased, right now it is decreased. If read count equal to, if read count will be equal to read underscore count, read count will be equal to 0, then you will go for signal. అబ్జర్వ్ చేయండి, మనం అప్లై చేసింది rw underscore mutex. ఇందాకేమో రీడ్ కౌంట్ ఈక్వల్ టు 1 ఉంటే వెయిట్కి వెళ్ళాం, ఇప్పుడు సిగ్నల్ అంటే యాక్సెస్ అయింది మీకు, ఓకేనా. సిగ్నల్, ఫైనల్లీ సిగ్నల్, ఓకే, mutex, okay. So this is what the point which we have to concentrate. ఇక్కడ అప్లై చేసిన విధానం ఒకసారి గమనించండి. సో లుక్ at this, hope that it is visible to you. Look at this, mutex అంటే రీడ్ మోడ్ లో అప్లై చేస్తున్నారు. రీడ్ మోడ్ లో అప్లై చేయగానే రీడ్ కౌంట్ పెరిగింది. ఇఫ్ రీడ్ కౌంట్ విల్ బి ఈక్వల్ టు 1, అంటే మోర్ దెన్ 1 ఉన్నట్లయితే, యాక్చువల్గా ఇక్కడ రాయాల్సింది గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు రాయాలి. గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు రాస్తే కరెక్ట్, మరి ఈక్వల్ టు టెక్స్ట్ బుక్ లో ఈక్వల్ టు. when it is greater than or equal to 1, read write mutex will be goes for waiting state. So if it is greater than 1 in the sense, somebody is reading that particular, I mean taking read permissions from from operating system by on that particular process, okay. ఆ ప్రాసెస్ మీద ఆపరేటింగ్ సిస్టమ్ నుంచి రీడ్ పర్మిషన్స్ ఉన్నాయి, అందుకని మీరు వెయిటింగ్ లో ఉండాలి. ఎవరు రీడ్ రేట్ అప్లై చేసినప్పుడు వెయిటింగ్ లో ఉండాలి. అర్థమైంది అనుకుంటున్నాను నేను చెప్పేది. అంటే రీడ్ రేట్ చేసిన వాళ్ళు వెయిటింగ్ లో ఉండాలి. అండ్ సిగ్నల్ మ్యూటెక్స్ ఆ సిగ్నల్ రిలీజ్ చేస్తున్నారు. సో రిలీజ్ చేసినా ఉన్నా, యూ మే బి అప్లైడ్ ఫర్ రీడింగ్ ది కంటెంట్ విల్ బి రెడ్ బై యూ ఫర్ లాంగ్ పీరియడ్ ఆఫ్ టైమ్. ఆఫ్టర్ కంప్లీషన్ ఆఫ్ యువర్ రీడింగ్, you will apply wait the mutex one more time. This is the first time within the same implementation. This is the first time. First time will be always equal to taken plus plus. Second time mutex will be always taken minus minus on read count. Please remember this, it's very important. ఇదంతా కూడా ఒక ప్రాసెస్ సంబంధించిందే, read second time mutex will be gets, I mean wait will be gets activated or executed. Read count will be reduced. Previously it has been so increased. Let us say this is increased, now it has been reduced. Since it is reduced, you will be so access read write count, read write mutex, read write operation మీకు ఇప్పుడు allocate చేస్తారు. తర్వాత మ్యూటెక్స్ ఆఫ్ సిగ్నల్. ఇది విషయం. ఓకే, అంటే ఇక్కడ అప్లై చేసేటప్పుడు జాగ్రత్తగా వెయిట్ మ్యూటెక్స్ విల్ బి టేకెన్ ఫర్ రీడింగ్ పర్పస్, సెకండ్ వెయిట్ విల్ బి టేకెన్ ఫర్ read rate operation, for read rate operation. First weight mutex will be taken for reading operation, second weight will be taken for read rate operation. That's what you need to remember. Here it is increased, here it is decreased. Please understand. If it is equal to 1, you could wait for some time. Read rate operation should be wait for some time. If it is equal to 0, yes, you can take that particular read rate operation for doing your modification. So that is what the point, readers writers problem in